So now let's check the next exercise. It's called to sum, let's say version 2. And let's check what we already have, the condition. So you are given a sorted array of numbers and a target. So it means that our method will have two parameters. The first parameter will be an sorted array, and the second one will be our target, which we need to find. And what we need to return? So we need to find two numbers that in sum will give us our target. And also additional condition here is that indices start at 1, not 0, which means that, so you can check the next example. We have 2 and 7, which in sum will give us our target number. And in that case, in that task, we don't need to return 0 and 1. Why 0 and 1? Because 0 is index of 2 and 1 is index of 7. But we need to return 1 and 2. So not the index, but the position which starts from the 1. Okay. Now let's answer to some question. I think it will help you better understand the task. So what is this different from the original to sum? So in previous videos we already have the same task where we need to find the target in our array, but in that task, in this version 2, we have additional condition. So the second question is, the array is sorted, so how can we use that? And what pattern fits here? So let's answer to these questions. So what is this different from the original to sum? So the array is sorted. In original to sum, the array is unsorted, so we needed to use a hash map there. But here we can use a little bit more smarter approach to solve this task. So the second question, the array is sorted, how can we use that? So if the current sum is too big, we can move the right pointer to the left, and if too small, we can move the left pointer to the right. So because the array is sorted, it led us to make a decision at every step, to move these pointers, or left or right. And what pattern fits here? So in my opinion, we can use here two pointers, because we can use left pointer, which will start from beginning of our array, and left pointer, and the right pointer, which will start from the end of our array. So we will have two pointers, left and right, and moving toward each other until the sum will match our target. Okay, so now let's check how we can implement this. So first of all, let's create our method, the public static like usual. So we will need to return an array, of integer, because in the condition was mentioned that we want to get indices where these two elements are positioned, and also they should be increased by 1. So it should not indicate the index, but the position which starts from 1. So let's return an integer array. Let's call our method find targets sum in sorted array. So find target sum in sorted array. And also, how I already mentioned, we will have two arguments. So the first argument will be an array of integers. It will be a sorted array, and also we will have our target. Okay. Good. So now, because we already identified that here 2 pointers can be used, we will need these pointers. Yeah, so let's initialize them. Int left pointer, which will start from index 0, and right pointer, int right pointer, which will start from the end of our array, and the index will be length of the array -1. Cool. Now we will need to iterate through our array. Yeah, for that we can use while loop. And the condition will be that left should be less than right. Why so? Because we don't want to compare the same element. Yeah, so we always want left to be less than right, because if they will be equal, it means that we compare the same element. But we need to compare and to check the sum of the 2 different elements. So that will be the condition. And now let's check if the element from the left, so array left plus array right is equal to our target. If it is, so we can return true, because we have found 2 elements. Actually not true, because our method is not returning boolean, but we will need to return a new array where we will store the index left +1 and index right +1. Yes. But if they are not equal, this means that we need somehow to move our pointers or left or right, and let's do it. So let's check first of all. Yeah, so if the sum, we can copy this part. If the sum is greater than target, that means that we want somehow to decrease our sum. And because our array is sorted, we can move our right pointer to the left. But if our sum, let's put this condition, can do like this. Actually not, we don't need this else, because yeah, actually no, let's set else. So if it's not greater, but it's less or equal to target, then it means that we want to make our sum to be greater than it's now. Yeah, and for that we need to move our left to right. So we want to increase this element of this pointer. And if till that moment we didn't return this answer, it means that we already compared all sums, all possible sums in our array, and we didn't found anything which will be equal to our target. And in that case we can return an empty array. Okay, now let's check how this method is working. So let's call our method. Inside the first argument will be an array of integers. It should be sorted. Okay, and let's choose a target. So let it be 8. Now let's check how this method is working. So And what do we see? 1 and 7, so it means this 1 and 7, and in sum they will give our target 8 number. Cool, so the implementation is right. Now let's analyze our solution. So the time complexity is O(n) because we iterate through the array once, and each pointer moves at most n steps total. And the space complexity is O(1) because we have only 2 pointers, no extra data structures, and this solution is much better than the first one because there we have used hash map, and the space complexity was O(n). So I think that our solution is good, and we can keep it how it is.